Alright, my video stopped again. So here we go. I think I ended this, but if it got cut off, to check independent, you use this. You check to see if E and F is the same as F times E. And so here, B and M was 0.2, B times M was 0.12. These were different. That did not equal that, so we say not independent. These are your two checks. You can check independence using this, you can check independence using this. If F has no bearing on E, then that would be this. Next, given that the student has blue eyes, let's write that out. Notice I'm putting that second because it's given blue eyes. What is the probability that he or she is male? So that's different from this. Up here at Q, we did given the student is male, probability of blue eyes. And then here we're given blue eyes, what's the probability of male? So if we're just going to write this out using this equation, if I want the probability of E given F, or probability of M given B, it's the probability of male and blue eyes divided by the probability of blue eyes. So, what's the probability of male and blue eyes? That's 2 out of 10. So 2 out of 10. What's the probability of blue eyes? There's 3 out of 10 total. So the answer is 2 out of 3. Or 0.67. Actually, for AP, you want to round to 4 decimal places. 4 decimal places will cover it for AP, and that's Calc 2. If you think about it, given they have blue eyes, how many of them are male? 2 out of 3. 2 out of 3 are male with blue eyes, and that's 2 out of 3 right there. So the formula works. Sometimes it's easy just to use the chart. The formula will always work. What is the probability of picking 2 males from 10 if the pick is replaced? Pick is replaced. So imagine you got everybody lined up. Okay, so you got our 4 males that we're working with, and we got our 6 females. And I say, what is the probability of picking 2 males if the pick is replaced? Alright, so what's the probability of picking 1 male? Think about it like this. Probability of male and male. Now, because I'm replacing, these are dependent events, or independent. These are independent events, and to find the probability of 2 independent events, you just multiply the events. So we're just going to do the probability of male times the probability of male, like that. So what's the probability of picking a male out of here? There's 4 out of 10. It's the probability, now you replace the male, so then maybe you pick this male and you replace them. What's the probability of picking another male? It's still 4 out of 10. These are independent events. The first event did not affect the second event. And so you can easily find probabilities by just multiplying together. That's the probability of picking a male and picking another male. Alright, now this next one changes. What's the probability of picking 2 males if it is not replaced? So now you have to use this equation. Picking 2 males, you're going to go like this. So that would be the probability of picking a male times the probability of picking a male given a male was just picked. So let's use this same thing again. Probability of picking a male. Your first pick, you got 4 males out of 10 total things to pick from.
Good afternoon. I'll just get a few announcements in here. Don't forget you can purchase your football tickets for
you picked out a male.
football game against Portage, or I'm filling the
Now what's the probability of picking a male? So given you just picked a male, it's probability of picking a male.
Tomorrow's theme is
3 out of 9.
And also,
Alright, come on, let's get it over with. Let's go.
Intramural disc golf this fall. There will be an informational meeting in Mr. Pass room, which is C593, immediately following school next Wednesday.
There you have it. So watch out for replace versus not replace.
And following students, please come to the main
Alright.
office. Quinn Haggerty.
Okay, next. Another example. Sorry about that. Consider picking 52 cards from a deck. Deck of cards. So a deck of cards has 52 cards. It has 4 suits, right? It's got hearts,
So Mike
diamonds,
please come to the main office.
clubs, and what's the other one? Spades. Okay, so those are your 4 suits. You got 13 of each. 13 of each of these. The AP does assume that you understand what a deck of cards is. They might ask you questions about a deck of cards. So you got 4, it's called suits, and you got 13 of each suit, including an ace, a king, a queen, and a jack, and then all the way down to 2. There is no 1 of hearts. Okay, so what's the probability of picking a 2? There's a 2 of hearts, there's a 2 of diamonds, there's a 2 of clubs, there's a 2 of spades. So there are 4 out of 52 possibilities, which is 0.077. Just plug that in your calculator. Picking a 2 or a 3. Probability of a 2 or a 3. Now, because these are mutually exclusive events, being that you can't, there's no intersection of a 2 and a 3. There's no card that is a 2 and a 3. You can find this doing the probability of 2 plus the probability of 3. Okay, that's like what we did here. If they're mutually exclusive, you can just add the probabilities together. Okay, so that is 4 out of 52 for the 2s, 4 out of 52 for the 3s, for a total of 8 out of 52, which is 0.154. Or it's 0.77 times 2. It'd be the same answer right there, 0.154. What's the probability of picking a heart? There's 13 of those, there's 13 of those, 13 of those. So 13 out of 52, which would be 1/4, which would be 0.25. What's the probability of picking a face card? Jack, Queen, King. Those are your face cards, cards with faces on them. So there are 3 heart face cards, there are 3 diamond face cards, there are 3 club face cards, there are 3 spade face cards. So there are 3 times 4, there's 12 face cards in a deck. That's your probability there, 0.231. Picking a heart and a face card. Heart and a face card. How do we want to do this? We want to do it the long way, the short way? How many face cards are there? And how many hearts are there? How many of them? Oh, how many of these hearts are face cards? 3 out of 52. There's only 3 hearts that are also face cards out of the entire deck. So 3 out of 52 for this one. Now this gets a little bit more complicated. The probability of picking a heart or a face card. This is where that formula is going to be very helpful. Probability of heart plus the probability of face card minus the probability of heart and a face card. That's that formula from combining events. Alright, so on here this would be like finding a union. You can use this equation right here. So probability of a heart is 13 out of 52. Probability of a face card was 12 out of 52. We found that before. Probability of a heart and a face card is 3 out of 52. That was the overlap. For a total of if you plug this in your calculator, 13 plus 12 minus 3 is 22 out of 52, which is 0.423 for that one. Next, picking two cards and getting two kings. Picking two cards and getting two kings. So, this is a bad question, because they didn't tell you if you picked the king and then put it back in, or if you picked the king and kept it out. So this is actually a bad question. Now, picking two face cards with replacement. Let's try this one. Picking two face cards with replacement. So they gave us the context here. So in this scenario, the probability of picking one face card is 12 out of 52. You put it back in, and so there's still 52 cards, and there's still 12 face cards. You know what? I'm just going to plug that in my calculator like that, and you get 0.053. And now we're going to do without replacement. So you pick a face card. And suppose you picked a face card out. Suppose you picked one of them out. How many face cards are left? There's 11 left. How many total cards are left? Remember, you took it out of the deck. So there are now 51 face cards left. Sorry, 51 total cards left. You end up at like that. So probability is a little different when you replace versus not replace. Oh my goodness, this video is so long. Okay, what is the relationship of achievement and home ownership? Achievement being educational achievement. We got 500 total, so if we were to add these up, we would get 500 total. Okay, define the events as following. G equals is a high school graduate. H is a person is a homeowner. Explain in plain language what PG raised to the C means and find the probability. So what that means is this would be the complement of graduating. So it's the probability that someone did not graduate. Probability that someone did not graduate, let's see, it would be total of these. So you'd have to total these up. So these total up to 190. So 190 out of 500 for this one. What is that? 0.38. 0.38 for that. Next, make a Venn diagram.